Okay, so this is the key to worksheet 4.1 part 1, and on this worksheet you are graphing exponential functions. Now remember from the lesson that we've talked about that we discussed an exponential function has a horizontal asymptote, and when you look at the form of an exponential function, it looks like this: f of x equals b to the x plus, let's say, c, and then the c right here is your horizontal asymptote. Now the horizontal asymptote, remember, is a horizontal line. So a horizontal line is named, has the equation y equals. And so in this case will be y equal -5. So that would be your horizontal asymptote. Again, you must say y equals, just don't put -5 there. It is a horizontal line. Okay, now you do need to draw the asymptote also. So it's going to be, so it's at -5. So you're going to draw a dotted line like this. Y equal -5. Okay. Now remember, the graph, the exponential function, gets closer and closer to the horizontal asymptote, but it never crosses the horizontal asymptote or touches it. Okay. All right. So we're going to find the domain and range and the y-intercept. For the y-intercept, we can do that now. To find the y-intercept, you let x equal 0. So when let x equal 0, I get, remember this is y right here, if x is y, so I get y equals 2 to the x power, so that's 0 minus 5. So 2 to the 0 is 1. 1 minus 5 is a -4. So my y-intercept is -4. Now it does say plot at least 3 points. So I already know 1. We know the y-intercept. That's here. Okay, right here. So that's the y-intercept. All right, I need 2 more points. So we use a t-table. And we have y equals 2 to the x minus 5. Okay, so notice we talked about the fact that the base, see the space right here is 2? The base is 2. Since the base is 2 and the base is greater than 0, so since the base is bigger than 0, remember that means that the function is increasing. All right, so it's increasing. If the base was between 0 and 1, then the function would be decreasing. But this is increasing, so that means that it's doing something like this. Okay, it's doing something like this. All right, so that means. Okay, so that means that on this side, the graph is getting closer and closer and closer to the x-axis, to the horizontal asymptote without crossing it. Remember, it just never crosses it. Now, it's not a straight line, so don't all of a sudden draw a horizontal straight line like this. That's not what it's supposed to look like. Okay, so forewarns you right there. It's supposed to, the y value is getting closer and closer and closer to 0. They're still decreasing. It's getting closer and closer to -5, I meant to say, the horizontal asymptote. Getting closer and closer to -5, the horizontal asymptote. Now on this side, it increases rapidly. So that's where we're going to get our other 2 points. So let x be 1. So if x is 1, let's see what happens. If x is 1, I get y equals 2 to the first power minus 5. So that's 2 minus 5, which is -3. So I plot the point 1, -3, and that is about here. Okay, if x is 2, I get y equals 2 squared minus 5, which is 4 minus 5, which is -1. So I get the point 2, -1. So 2, -1 is here. And so then you can draw the graph at that point. Just make sure it looks like it's rising rapidly. So if you want to, you can go ahead and do another point. Let's say x equals 3. So if x equals 3, I get y equals 2 to the third power minus 5, which is 8. 2 to the third is 8. 8 minus 5, which is 3. So 3 is here. So I get something that looks like this. All right. So there's the graph of this exponential function. All right. So notice we have to do the horizontal asymptote first, and the horizontal asymptote is just this constant right here. So y equal whatever that number is. In this case, it's -5. To find the y-intercept, you let x equal 0, and you solve for y. And remember the fact that since the base is 2, which is bigger than 0, the base, I meant to say bigger than 1. If the base is greater than 1, the function increases. If the base is between 0 and 1, so a fraction less than 1 but bigger than 0, f of x will decrease. All right, so this should have been bases greater than 1. So since the base is greater than 1, it increases. Okay? All right, now let's talk about the domain. Domain, if you look at this, as you go along the x-axis, so if I look at negative 200 right here, if this is negative 200, am I going to get a point on the graph? Yes, it's going to be closer and closer to negative 5. Even 1 million, negative 1 million, be closer and closer to negative 5. So remember this, the y values get closer and closer to negative 5. So like negative 4.99, negative 4.999, negative 4.99999, and so on. Right? It's getting closer and closer to negative 5 without actually being negative 5. This will never be negative 5. This y value here will never be a negative 5. It'll get close to it, but not be a negative 5. So the domain then is from negative infinity all the way to infinity. So from negative infinity all the way to infinity. Now the range, remember, that depends on your horizontal asymptote and whether the graph is above or below it. So your horizontal asymptote is y equal negative 5 and the graph is above it. So if you're going to start at negative 5, you always start at the horizontal asymptote, negative 5. But remember, there is never a point on this graph in which the y value is negative 5. It's close to it, but not negative 5. All right, so we're going to say parentheses negative 5, parentheses because y will never be a negative 5, but it'll be close to it. So it's parentheses negative 5 all the way to, and the arrow keeps on going up, so it's infinity. All right, so there's the graph of the first one. All right, the second one. Okay, now, so your horizontal asymptote, again, this is an exponential function. The base here is a half, though. This right here, remember, that's a reflection. Okay, so the horizontal asymptote is y equal 4. That's up here, y equal 4. So you draw the horizontal asymptote. All right, now, you see how this is reflection right here? So that implies that the graph here will be below the horizontal asymptote. All right, so it won't be above it, it will be below it. So you can see what that's going to look like. So this is going to be below. Now remember the negative out in front, remember in terms of transformations that was a reflection about the y-axis. All right, so when you graph, remember though, when you graph y equal 1/2 to the x, you'll get a function that's decreasing like this. Then you reflect it about the x-axis, then you move it up 4 units. So that's why the horizontal asymptote is y equal 4. But basically, since we already did the horizontal asymptote, the negative out here just says that it's going to be below the horizontal asymptote. Okay, so below the horizontal asymptote. All right, so now if that negative wasn't there, remember what that 1/2 implies. If the negative wasn't there, remember if the base is greater than 1, the function increases. Okay, since the base is between 0 and 1, a half is between 0 and 1, the function will decrease. So it'll do something like this. Okay, it will decrease. But there's a negative out in front. So what that does is it reflects it about this horizontal asymptote. So it's going to actually do this. So you see what it's going to look like in a little while. All right, let's find the y-intercept first. So to find the y-intercept, we're going to let x equals 0. So I get y equals negative 1/2 to the 0 power plus 4. 1/2 to the 0 power is 1. So I get negative 1 plus 4, which is 3. So notice that's right here. Okay? All right, so let's get a number, another 2 more points. So if x is 1, let's see what we get. If x is 1, we get y equals negative 1/2 to the first power plus 4. So that's negative 1/2 plus 4, which is 3.5. 3.5, so that's here. So 3.5 is here. Now what I've found is that this part, the graph goes towards the horizontal asymptote over here. That's what I just found. But then I got to find out what goes here. So what happens here is that it falls very rapidly right here. So I got to pick 2 more points. Let's pick 2 more points on this side. So let's say x is negative 2. So we found 3.5 here. So if x is negative 2, let's see what happens. You may need to use your calculator for that. But I get y equals the opposite of 1/2 to the negative second power, because that's what x is. See right here, 1/2 to the negative second power plus 4. Now, you should remember that 1/2 to the negative second means this. Without using a calculator, it means 1/2 to the negative second means the same thing as 2 to the second power plus 4. So that's negative 4 plus 4, which is 0. But if you didn't remember that, then use your calculator. So don't guess at it and get it incorrectly. Use your calculator. You have access to a calculator. So what you would do in your calculator for this part right here, you would say negative, in parentheses, 1 divided by 2, close the parentheses, then say raised to the negative second power, just like this, and then add 4. And when you do that, you get 0, which is what it's supposed to be. All right, so you get negative 2, 0. So negative 2 zeros here. Let's pick another point. Let's say negative 3. So if x is negative 3, I get y equals the opposite of 1/2 to the negative third power plus 4. And on a calculator, let's see what this is. Now, without a calculator, this would be 2 to the third power, so that would be 8. So it would be negative 8 plus 4. This would be negative 8 plus 4, which is negative 4. But let's use the calculator. So you would say negative, in parentheses, 1 divided by 2, close the parentheses, raised to the negative third power, and I'm going to add 4, and you get negative 4. Okay? So negative 3, negative 4. So negative 3, negative 4 is right here. And so you get something that looks like this. All right, so there's your graph there. And then notice that the domain, so my y-intercept, we said was 3, right? So that's 3 right here. You can say 3 or you can say 0, 3. Doesn't matter. Okay, now the domain, remember, is a set of x coordinates. So you go along the x-axis. So if I'm looking at negative 1 million, I'm going to get a point on the graph. It'll be way down there. See, this graph keeps going down like this. So it'll be way down there. And as I get bigger and bigger and bigger over here, my y-value is getting closer and closer to negative 4. So negative 4.99, negative 4.999, and so on. Okay? All right, so it'll be negative infinity to infinity. All right, now your range, you go along the y-axis from bottom up. Notice this points towards negative infinity. So we're going from negative infinity all the way, and notice the largest my y value become is very close to 4. So we at the horizontal asymptote 4, but it's parentheses because it never actually is 4. It's very, very, very close to 4. So negative infinity to 4 parentheses. Okay, so that was the key to 4.1 part 1.